In section 2.4, we're dividing polynomials with both the long division and synthetic division. And then we're using the corresponding topics of the remainder and factor theorems that are based upon those divisions. First up, the objectives. Like I said, we will be dividing with long division. And then the easier cases, we'll also be able to use synthetic division to divide polynomials. The difference, long division will never fail to work, where synthetic division is only going to be a case that works whenever we have a linear divisor. But it's easier, so oftentimes whenever it does work, people prefer synthetic division. From the basis of that division, we're going to be able to evaluate a polynomial using the remainder theorem, and then use the factor theorem to solve a polynomial equation. Okay, first up, let's talk about long division. Let's say I gave you the polynomial function 7 minus 11x minus 3x squared plus 2x cubed, and I ask you to divide that by the binomial x minus 3. Well, the first thing is, whatever you're trying to divide into, and the divisor in that case as well, both must be in descending order. Well, my divisor, x minus 3, it's already in descending order, but what I'm dividing it into is in ascending order. That does not work. So the first step is to rewrite what I'm dividing into descending order. So I put 2x cubed minus 3x squared minus 11x plus 7. Now notice, I take my x minus 3 and I divide it into that cubic polynomial, 2x cubed minus 3x squared minus 11x plus 7. And the first step is saying, how many times will x divide into 2x cubed? You said, well, 2x cubed divided by x is going to go 2x squared times. Now, typically, you want to put the answers over the same power that's within the problem. So when I knew x goes into 2x cubed 2x squared times, I put the 2x squared term over the 3x squared term inside the quotient. Now, 2x squared times x does give me 2x cubed. And then I say 2x squared times a negative 3x, that would be 2x times a negative 3, that's going to be a minus 6x squared. But then I need you to remember, we're always subtracting these out. That's why I put a plus 6x squared right there. Now, in my homework solutions, you'll see I put minus, and then I put a parenthesis. Everything else is subtracted off. Here, I've just went ahead and changed the signs because I know I'm subtracting it out. That's why this first term, the 2x cubed term, does cancel out. And then I'll be left with negative 3x squared plus 6x squared for a positive 3x squared. I bring down my minus 11x. I could have also brought down my plus 7. Doesn't really matter. Now, in this next step, I say, how many times will x divide into 3x squared? And I say, well, it'll go into 3x squared 3x times. So please notice you put a plus 3x right here. Now, 3x times x is a 3x squared. 3x times a negative 3 would give me a minus 9x. Why do you see a minus 3x squared and a plus 9x? Because you're always subtracting out what you put inside that group. So you can think of it as, well, that's going to be a minus 9x, but since we're subtracting it out, it becomes a plus 9x. Again, in my homework, I'll have a minus and I'll have a parenthesis after it where you know to subtract everything inside that group. Here I've went ahead and changed the signs so that we can see, yep, the 3x squared terms cancel out. I'll have negative 11x plus 9x is minus 2x. Now my final step in this problem is I would say x will go into negative 2x. Well, negative 2 times. Negative 2 times x it would be a negative 2x. Negative 2 times negative 3 would be a plus 6. Now, why are those the opposite signs? Because you always subtract out the multiplication of those. So I went ahead and changed those signs. That's why the x terms cancel here. And then you would have 7 minus a 6 or 7 plus a negative 6, and you'll get your 1 there. Now, the way we write our final answer, this original problem, 2x cubed minus 3x squared minus 11x plus 7 divided by x minus 3. is equal to 2x squared plus 3x minus 2, and then plus the remainder 1 that's still divided by your divisor, x minus 3. Final answer there. Now, if we're using synthetic division, let's say I wanted to divide x cubed minus 7x minus 6 by the binomial expression x plus 2. The first thing I want to make sure that we get correct is what the synthetic divisor is. What you always have to do is find the 0 generated by the factor that you're trying to divide by. So in this case, I'm trying to divide by the binomial x plus 2. To find the synthetic divisor, I just set x plus 2 equal to 0. And I can say, well, if x plus 2 is 0, then x is equal to negative 2. Well, x equals negative 2 is your synthetic divisor. Once you have that, you're ready to perform the synthetic division. So now, please notice here on this next page, and I wish I would have wrote the problem on here again, but whenever I'm using this synthetic divisor, unlike whenever we use long division, you really don't have to have any zeros. If you skip a term, like if I didn't have an x squared term there, I wouldn't have to put a plus 0x squared. I could, but I don't have to. Here, I absolutely have to. So if I'm trying to represent the polynomial x cubed minus 7x minus 6, then I know that that's going to be 1x cubed plus 0x squared minus 7x minus 6. So 1, 0, negative 7, negative 6. Please notice my term that I'm using to divide into now has coefficients of 1, 0, negative 7, and negative 6. Now, had I forgot this 0 there, since you said, well, you didn't have an x squared term, what if you just didn't put the 0 for that? Then this would be understood to be 1x squared, and then I would have minus 7x minus 6 if that 0's wasn't there. So the way I need to read this is my constant, this is the coefficient of x squared, which makes this the coefficient of x cubed. Now, as we already discussed on the previous page, negative 2 is your synthetic divisor. The way that we use synthetic division is you take that synthetic divisor into each of our coefficients, including any 0 coefficients of our term. We bring the first term down. And you'll say, okay, the 1 comes down. Negative 2 times 1 is negative 2. Now, in each of our other columns, we're just going to take the sum. 0 plus negative 2 is negative 2. Again, we multiply. Negative 2 times negative 2 gives me a 4. So then I can say, well, negative 7 plus 4 is negative 3. Negative 2 times negative 3 is a positive 6. And we know the sum of the fourth column, negative 6 plus 6, this gives me a 0. That last answer is always going to be your remainder. And so then you can say, well, then this is going to be my constant. This is going to be my x term. This is going to be my x squared term. Your answer is 1x squared minus 2x minus 3 and no remainder. So you just say the quotient or the solution is x squared minus 2x minus 3. In this case, it divided evenly. Now, notice I said in this case it divided evenly. The reason I knew it divided evenly is because I didn't have a remainder. So what the remainder theorem is saying is that if the polynomial is divided by x minus c, and you know anytime you're dividing by x minus c, your synthetic divisor is going to be you're synthetically dividing with x equals c. And what this is saying is that, well, the remainder theorem is saying, well, if you're using that as your synthetic divisor, then your answer, whatever you get for your remainder, is going to be f of c. So in other words, we know it divides evenly if we get a remainder of 0. If we get a remainder of anything else, it's the same thing as just plugging that value into the function, and it's giving us the f of c. To see that, let's look at a problem. Let's say I give you the polynomial f of x is equal to 3x cubed plus 4x squared minus 5x plus 3. And I'm asking you to use this remainder theorem that I just mentioned on the previous page to find f of negative 4. You say, no problem. All I have to do is synthetically divide with negative 4 into a polynomial with coefficients of 3, 4, -5, and 3. I don't have to put any zeros in there because there was no power of x that was skipped in this problem. Okay, synthetic division says bring down the first term. -4 times 3 is -12. Sum the next column. 4 plus a -12 is -8. -4 times -8 is a positive 32. -5 plus 32 is 27. -4 times 27. I know 4 times 20 is 80. 4 times 7 is 28. So -4 times 27 is going to be -108. I sum that column. 3 plus a -108, I get -105. So what I know in this case is that, well, -4, or the factor x plus 4, does not evenly divide into this polynomial. When I try, I get a solution, or I get a remainder of -105. Now, what that tells me is that that -105 is also the solution to if I were to plug -4 in for x in your original function. So I promise you, if you said 3 times -4 cubed plus 4 times -4 squared minus 5 times -4 plus 3, you're going to get a -105. So that's just telling us that remainder, it's whatever the function's value is at that specific value of x. Now, because of the whole idea of this remainder, you're saying, well, it doesn't divide evenly, and instead it's giving me whatever the function is at that specific value of x, it's giving me f of c if I have a remainder. Well, if that remainder is 0, it's telling me that x minus c is a factor. So the remainder theorem and the factor theorem, it's really saying the same thing. So it says if f of x is a polynomial, if f of c is equal to 0, well, that's telling you that x minus c is a factor, and that c is a root or a solution, and the factor x minus c is a factor of x. If x minus c is a factor of x, then the function evaluated at c is equal to 0. That's the whole point of calling it a 0 or a solution. At that specific x value, the y component is 0, which means you don't have a remainder at that point when you use your long division. Now, let's look at the equation 15x cubed plus 14x squared minus 3x minus 2. Now, if I were just asking you to factor that out and solve for x for me, it'd be pretty challenging because you're not going to be able to factor by grouping in that one. You can't simply just, well, I'll group the first two and group the last two and hope for the best. Well, it's not going to work. So instead of factoring by grouping, we're going to use this new concept of the remainder factor theorem. Now, what it's saying is that solve this equation given that I'm already telling you -1 is a 0 of that function. So the fact that we know that -1 is a 0 of that function tells us that x plus 1 has to be a factor. So if -1 is a 0, then x plus 1 is a factor. Now, we are given that -1 is a 0 of this function. That means f of -1 is 0. Because f of -1 is 0, the factor theorem tells us that the corresponding factor, the factor that would give you a solution of x equals -1, is the factor x plus 1. That's a common mistake students will make here. They'll think that x minus 1 is your factor. That would be terrible. It's always the opposite of that sign when you put it in the back into factored form. So that factor theorem tells us that x plus 1 is a factor. We'll use synthetic division to divide this out. Now, if I want to use synthetic division to divide by the factor of x plus 1, I still use my 0. If x plus 1 is a factor, then I have a 0 at -1. I use -1 in my synthetic division. My polynomial had coefficients of 15, 14, -3, and -2. That's where you see I got this from. We bring the 15 down. -1 times 15 is -15. We have positive 14 plus -15. Sums give us -1. -1 times 1 is a positive 1. We sum the next column. -3 plus 1 is -2. -1 times -2 is 2. And we already knew that this was going to be the answer because we knew x plus 1 was a factor. We knew -1 was a 0. Anytime that's the case, you better get a remainder of 0. And we did. So what this tells us right now is that if we take that original polynomial that we were trying to factor and then solve, well, if you divide it by the factor of x plus 1, you're left with a factor of 15x squared minus 1x minus 2, and then again, remember, that's plus no remainder. So it gives me this polynomial left over. So I could rewrite in factored format that original equation, 15x cubed plus 14x squared minus 3x minus 2, would factor to be x plus 1 times 15x squared minus x minus 2. Now, in this one, that's not going to be hard to further factor. Once you get it down to the quadratic, you have a couple of options. You could just say, well, to find your remaining solutions, you could use the quadratic formula. That certainly wouldn't be bad. In this case, though, since I know 15 and 2 have pretty obvious factors, I can say, well, 15x squared is going to be 5x times 3x. I know the only two numbers that multiply to get a -2 are a -2 and a 1. So you'll see now on the next page, I can say, well, all right, this 4-term polynomial factored to my linear factor times my quadratic factor. That quadratic factor can further be broken down. 15x squared is 3x times 5x. I know -2 is 1 times -2. Now, I had to get the signs in the right place here because that middle term had to be a minus 1x. Well, notice it would be. You would have your 15x squared minus 6x plus 5x gives me my minus 1x back, and then I would have my minus 2 at the end. So I know that this is in factored form. And again, if you preferred, instead of factoring that quadratic out, you could have used the quadratic formula to solve for x there. But I kind of like the factoring here. Now, once I get it fully factored, then I just set each factor equal to 0. The factor of x plus 1 gives me a solution of x equals -1. The factor of 3x plus 1 gives me a solution of x equals -1/3. And the factor of 5x minus 2, that would give me 5x is equal to 2, x equals 2/5. So my solution set from low to high is going to be -1, -1/3, and 2/5. Now, again, keep in mind, that is the solution to the equation that I ask you. When does this function equal 0? So sometimes whenever we're setting things equal to 0, students are wondering, well, why are you setting it equal to 0? Because that's what the equation wanted us to do. We wanted to know what values of x are going to satisfy when this function is equal to 0. And that's what we've done right here. We can say the zero product property says that 3 terms being multiplied are equal to 0 when either the first term is equal to 0, we get this solution, or the second term is equal to 0, we get this solution, or the third term is equal to 0 and we get this solution. So all 3 are solutions, and we have our solution set there. Beautiful problem. All right, guys, that finishes up the 2.4 notes. Please make sure you try the homework in this section on My Math Lab. And as always, compare it with the solutions to the problems that I've done out of the book that should correspond to your My Math Lab assignment. And let me know if you have any questions. I'll be happy to help.